All right, everybody, let's talk about everybody's favorite topic, which is, of course, statistics. So this is actually the beginning of Statistics for Nursing, which is actually a really easy book to read. If you haven't had a chance to look at this before you go through these first few slides, this is written by a nurse. So it is for nurses. So it is not statistics in the dry way that we talk about it. She actually relates it a lot to statistical practice in nursing. So it does make a nice difference. It's very easy to read. The chapters are very short. So don't let this intimidate you when it comes down to statistics. We are going to break it down bit by bit. So this is Statistics Chapter 1. So why do I need statistics? Let's get myself out of the way here. Oh, here we go. Okay. Why do I need statistics? You can't tell if it's fake news without understanding your stats. All right. How many of you have seen fake news recently on Facebook? I know you have. And you can't apply research data or create your own without statistics. Statistics are as easy as things like ratios and percentages, all the way up to huge charts and processes and concepts that we're not even going to cover in this class. You are, in fact, a better person in the world for it. So we have a lot of false news out there, regardless of what your political views are. You guys have seen Facebook, you've seen Instagram, or what is it the kids use these days? Snapchat? Snapchat has statistics in it? Probably. Think about all the dumb Facebook stuff you can avoid just by understanding some basic statistical information. So, this is a little thing about how to spot false news. I think as nurses, especially with this the current problems in the world with the coronavirus and a bunch of other things that we don't normally talk about, it's really our job to point out things that are not right to the general population. So read beyond. Part of statistics is reading way past the headline. Even in statistical articles or journal articles, the author will try to grab you with a headline that may not be what the study is. It doesn't make the study a legitimate study. Consider your source of information. Again, People magazine is not going to be your best source of information when compared to Time. Time's not your best source of information when you are talking about an academic journal. So knowing what your source is can make a big difference in how valid the research actually is. Do a search on the author. For research studies, we don't typically know a lot about the authors, but there are certain people that put things out into the world that we know are not true. So if an article is written by them, probably not the right person to believe. Check the date. It should be new. Is it a joke? Okay, we laugh about that. In research studies, that's not a problem. In Facebook, it is. Are there supporting sources? Anytime you're in an article, they may not have direct hyperlinks to the sources that they used, but you should be able to go back to their works cited or their reference list and find the sources of information that they actually used to create this study. So, that's a lot of background research, but if you're concerned about the validity of a study, that's something you should be doing. Check your biases at the door. We know that we have biases internally. There's nothing we can do about that, but we can adjust for them. Was it authentic? And then, of course, check your mainstream media. Mainstream media sources have a responsibility to double check their information. Any source that puts information out very quickly after something should be double and triple checked. So if they're not doing that, it's not a reliable news source. All right, so population versus sample. This is empirical evidence, all right? It's a systematic observation and experimentation. Variables are the characteristics being measured, and probability is the likelihood of the possible outcome, all right? So for example, in this example on the side here, we have a bunch of girls and a bunch of boys and a bunch of men and women. Okay, our job in this population is to come up with a sample that represents all of those people. Okay, so the probability that there are clearly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 little girls here, and there's only 1, 2, 3, 4, 5 little boys. So the probability of choosing more girls than boys is a realistic problem. So we have to look at both of those things and make sure that our sample actually represents what our population is. So here you can see in their sample we have 2 little girls to 1 little boy. So that's the same as the population. So if the population truly has more girls than boys, they should be more highly represented in your sample. Okay. The problem that we come here is If your probability in your population is that your girls are going to be higher than your boys, but in your sample your boys are higher than your girls, you're not creating a realistic version of what this looks like. Okay, quantitative versus qualitative. So quantitative data is quantifiable, meaning there's numbers associated with it. Now I don't want you to use numbers as the only example because qualitative data can use numbers too. But this is quantifiable stuff like temperature, all right, the weight of the patient in kilograms. That is a quantifiable piece of data. It's objective information that can be replicated by different scales, different measurements, things like that. Okay. So for example, if your scale is tested to be sure that it is accurate, it should be the same exact measurement as the scale next to it that's also been tested to be accurate. Qualitative is the quality of things. It's a description of something. So is it warm or is it cold? The quantitative data of is it warm or is it cold is the temperature is 99 degrees outside versus it feels hot outside. Okay. It does not contain quantities. Again, that does not mean that it doesn't contain numbers. It means that it doesn't contain specific quantities in what they are measuring. So don't get confused between those two things. All right, we have independent and dependent variables as well. So a variable controlled by the researcher is the independent variable. We don't want too many independent variables in research because we can't tell if we switch or change one thing, how that affects something else. So we typically try to keep it to one or two independent variables in a research study. The dependent variable is the outcome variable. So it depends on something to happen. So we fix this or change this by saying we're going to change something about the independent variable and the dependent variable will change because of it. So in this experiment here, are test scores impacted by the amount of time spent sleeping the night before a test. Okay, so the independent variable is the amount of sleep the person gets prior to a test, and the dependent variable is the grade that the person gets on the test. So here's a few more examples. You're monitoring the relationship between urinary tract infections in patients with a Foley catheter and patients using a PureWick. So the independent variable is the use of a Foley catheter or the PureWick, and the dependent variable would be the number of urinary tract infections. What about if you're monitoring or trending a troponin on a patient versus a patient without a positive troponin? The patient with a trending troponin is increased shortness of breath. So the independent variable is the level of the troponin. The dependent variable could be shortness of breath. All right, same thing is true for if you're monitoring a type of IV catheter use in successful tries. Your independent variable is the catheter that you're using, and the successful tries is the dependent variable. So what we're trying to say here is if we use catheter A, it took us 4 times to try. If we use catheter B, it only took us 2. So because we used catheter B, the dependent variable is the number of tries. Okay. We have a lot of different types of variables. So there's continuous variables, and those are variables that fall on a continuum. For example, temperature. You can go all the way from -4, let's say, in temperature, all the way up to 102 in this area. Weight is on a continuum. You can start out weighing 6 pounds, but you can go all the way up to 600 pounds. So that's all on a continuum. There's also categorical variables, and those are a finite number of groups or categories, and things like that include race, right? There's a lot of variation to race, but if we break it down to the 5 main ones, we have Caucasian, African American, and so forth, okay? So if you are using race, you're not going to have a lot of variables to choose from. It is what it is. It's a categorical variable that's finite, meaning there's an endpoint. You also have data that can either be nominal, which is not greater or less, but different. So for example, if we were to do a study about baby gender names or baby names as a whole, if we went to the OB floor and we looked at every single patient that had been born within the last year and we tallied up the names that matched, that would be an example of nominal data. One name isn't necessarily better than the other. I'm sure their parents would disagree, but one name isn't better than the other. It's just different. All right, same thing is true for gender. Again, men aren't better than women, women aren't better than men. They're just different, and it's a clearly definable data point. The answer can't be both or neither. So, that gets a little sticky. If we're talking about patients who have changed gender, they can't be male and female, right? It's one or the other, or you need to have a category in there that specifies that they're both. And then ordinal is exhaustive and inclusive, but ordered by rank. So, for example, people who graduate, there's a valedictorian, and then there's a person who graduated at the last of the class. All right, there's a limit at the bottom and there's a limit at the top, but it's all inclusive and then organized by rank. So we would organize it from the least effective student to the highest earning student. Okay, some other examples here. Again, nominal, not greater or less, but different. We kind of talked about that one already. Ordinal is exhaustive and inclusive, but by rank. So we look at satisfaction scales here too. So for example, on a scale of 0 to 10, how satisfied were you with this PowerPoint? All right, if you were not satisfied, you're going to pick 1, 2, 0 even, maybe. If you're super satisfied, you're going to pick a 10. We can rank that. We can rank wealth. We can rank all kinds of things. Interval data is exhaustive, exclusive, and rank ordered with equal intervals. So, for example, in wealth, I could make anywhere from $15,000 a year all the way up to $2 million a year, or further. Interval data is when that data is specified by a certain amount every single time. So, for example, temperature. We're not going to do it's 99.12 degrees, right? We're going to say it's 99.6, 99.7, 99.8. All right, so there's an interval difference that's equal between all parts. Same thing for age groups. We can say ages 0 to 10, 10 to 20. So the number in between those groups is the same. And then there's ratio data. And that's all of the above, and there's a point at which it disappears. So a good example is blood pressure. There is a certain point that there is no blood pressure, right? A deceased person does not have a blood pressure. So normally we talk about blood pressure in interval data form, right? We have a blood pressure of 100 or 102 or 104. We have a ratio there that we can measure it by. It's exhaustive because it can go up to a certain point, it can go down to a certain point, so it's ordinal interval data that needs a endpoint, and the endpoint being 0. You cannot have a blood pressure lower than that. So here's an example of our levels of measurement. And again, let me get myself out of the way here. So nominals are named variables. Ordinals are named and ordered in some way. Intervals are named, ordered with proportionate intervals between variables. And then our ratios are named, ordered, proportionate, and can accommodate that absolute 0. So it's just a listing and the type of levels of measurement that we have.